Okay, let's get started. All right, so you guys should have seen the new assignment 2 been published. And my graders are working on assignment 1 to get it graded within, hopefully by this time next week. Okay, so you'll see this. Hopefully, we'll see the results. Hopefully, nothing really kind of confused you in a very tremendous way. Let's see. Another question that came up right before this lecture started was about the semester project. So you can, even after you submit the proposal by that deadline I set up, you can change your project idea or concept even after that proposal. But I just, if you do so, then you're just gonna have to scramble quickly because you're just gonna have to do maybe the similar amount of work in a shorter amount of time. Okay, so you can change your project idea and concept. And another thing is that most likely, most of the project concepts I will accept. I mean, like, I'm not going to say this is a failure of a concept or proposal, but what I will do is I'm going to give feedback, maybe saying maybe the concept is too broad, or what are the specific, I might ask you questions like, where are you trying to go with this idea? Okay, so it's not like anybody's going to fail on the project proposal. Okay, but you got to submit something to not fail. Okay, so any questions about that? Okay, I lost this monitor, so I can't really, I used to be able to kind of look at my notes and talk about the slides. So I have to kind of do everything on one screen instead. Okay, so lecture 5. So we're still going to talk, yes?
By giving the code part or only like the paper?
I can't quite hear you.
Do we have to submit the project like using the code or only the paper for that?
Oh, for the proposal or for this actual project?
I mean, like at the end of semester, do we have to submit a code for that project?
Yes, I expect the Jupyter lab file along with the report. Okay. Thank you for pointing that out. I'm going to take note of that and then make sure I let the others know who don't come to class. And you know, some students have come to me about project ideas that were not based on Python, meaning they were thinking about using something else other than Python, specifically like R. And that student was doing like a research project, like a work research project using R. And so he kind of wanted to kind of like do both work simultaneously. And I declined his idea about using that because the intention of this class is to learn how to use Python in these concepts and not using another language, okay? So that's the reason why, like, even though I showed you that other thing last week about the Apple framework for machine learning, it was just more of a, hey, this is interesting kind of thing, but it's not like an idea for you to go ahead and actually work on something based on that. I mean, you could, if there was an actual plan of using your Python work and then using an iPhone app to demonstrate it, okay? But I still want the bulk of the data analysis, data exploration, and the models to be built with Python. Okay, all right. So we're going to be using within Panda and Panda DataFrames. And now we talked a little bit about DataFrames being basically like this Excel spreadsheet, two-dimensional tabular structure. But with the DataFrames, we're going to be talking about different kinds of operations that you can do with DataFrames to condense or group data together. And one of them is using an operation called pivot. And we talked about it a little bit the last lecture. So we're going to be using pivot in Panda to aggregate our data. So what you might get is when you aggregate these data together, let's say by year or by name, what you might find is that there might be some groupings where some rows or some columns, the data won't be there because there wasn't any data there when before it was collapsed. So when it was then collapsed together, you got some no data there. So you might see something called NaN there. So if you look at the baby names and aggregate it across, like say the sex, look at the aggregated by sex and then look across all the names, you might find some unexpected values there. And we can try to do also some of this debugging with VS Code. Doing debugging with the browser with Jupyter Lab, the only way that I can know about debugging that is, and even with Jupyter Labs, I mean with VS Code, is by putting print statements, okay? I haven't really found any really better way to do debugging of doing various steps within Jupyter, other than by putting in various, like breaking down the steps into smaller steps, and then putting in print statements to help you understand if you're doing something wrong. Can we use something else for some real-time debugging? Yes, but you won't be able to submit those files for your either assignment or for your final project. You're still going to have to stick with, you have to convert that code back over to Jupyter Lab to submit that for your assignment or for your semester project. We try to demonstrate that for you. And what I mean by doing some, oops, not that. So this is sort of a snippet of code that, here, sorry, this one here. This is a snippet of code that comes from the lecture 5. You see lecture 5 here. So this is what I uploaded to Canvas, is some demonstration about using things like pivots and so forth. So here's a pivot after loading the baby names into a data frame. And here you can see that you can pivot the data and you can sort of explore what that data looks like. Now, here is a specific case where doing the pivot, you run a certain function that you want to do, and you want to focus in on a certain column of data. So if you look back at this, the raw data of this baby names, this is the raw data, at least the first 5 rows. You can see that Mary exists in a certain year, and how many babies named Mary were born that year, and so forth, right? So here in the pivot, we're saying we want to group it by, we want to do the pivot based on names, and then we want to focus in on the count column. So the count column is a numeric column like this, right? And here we want to run some functions on that, either the max, min, or down here, you can see that I do this specialized function of AMMD. But let's say that you write this function and it's not working the way that you think it should be working. So you could try, what I did was I kind of showed you an example of me putting in some print statements in there, okay? You can uncomment out those lines and then see, so if I run this, let me run this again here. Okay, so if I uncomment out these lines and just run this one cell again. Oops. Okay, there we go. You can see when I actually invoke that function off, when I actually use the function, you can see that this is the actual series of data that comes through. This is actually the indexes of the which rows they were pertaining to, and this is the count values. And so you can see that the, and then when we do the calculate the result, you can see that the result was 2, which is 7 minus 5, right there, right? So you can sort of understand that. But let's say that this function was a little bit more complex, or maybe it wasn't quite working. It wasn't quite evident from this Jupyter print statements. So you could go and actually sort of mimic this in PyCharm or any kind of other Python debugger. And you can sort of set it up in a similar way. And you can actually put a debug statement here. Run, let's see, debug. Oops. I think it just ran without stopping. Oh, it's the wrong file. So here. So now this is the first time it comes to this function, because what it's going to do is for every group, so we ran this pivot, and every time we see a group of data with that name, it's going to call this function and say, now do this function, right? So you can see here, here's a series, but when you look at these Python objects with the debugger, might get overwhelmed. And it might be, how you say, too much information, more than what you wanted to know, okay? So you can get a little bit maybe lost in these Python internal objects. Oops, what's going on here? Okay. You can get a little bit lost in these Python internal objects, but if you kind of know what you're looking for, like for example, you can sort of see in that first line here, this first part right here, this is actually the condensed version of the series that's coming through this function. So if I say run and continue right here, here's the second set. It's only one data object within this one segment. That's why the result would be 0 for this. Run it again. This one's a much bigger set. And you can see, hopefully see that maybe the small values like 20, another value like 135, etc. And maybe the difference here might be like 120. So if I just took out the breakpoint and let it run, and then look at the results, it's kind of like what I predicted, right? The first one was 2, second one was 0, third one was 100, I said 120, this time it's 140 actually. So there was probably another value that was even smaller than I had seen. So this is just techniques for you guys to learn and hopefully use in your journey as using Python for machine learning, because the the tools within Jupyter Lab even through VS Code is pretty limited. Okay. And there's a lot of helpful things that you can probably have maybe discovered through VS Code. So one other toolkit that I among the data scientists that I talk with and communicate with, and I also see what their kind of tools they're using. They use another VS Code variant called Cursor. Have anybody here heard of Cursor? So it's a fork of VS Code. So they took a snapshot, whatever, of VS Code, and they made a more specialized version of another tool called Cursor, which really more specializes in doing have a lot more AI bots in it, and actually be more tailored for data scientists. And so, but you can actually do this. There's a lot of functionalities that VS Code has extended that makes the distinction between Cursor and VS Code even smaller. Like, for example, if I say I highlight this row, this cell, and I right click, and then see Copilot. So you have to have the Copilot part installed, and it says explain this. So you can highlight a certain line, like a certain cell, and if you don't quite understand what's going on, or like you copied some code from me, or you got some code from somebody, and you're trying to build up your either do your assignment or do your project, and you don't quite understand what's going on, you can have it Copilot sort of explain it to you a little bit more terse way. Okay, I mean verbose way. So these are all different kinds of tools that you should use as a data scientist student. Okay. Going back to the lecture. So GroupBy. So here, as I talked about pivots, that's what we can do with pivots. And then also we can do the same thing or similar thing using GroupBy. So if I'll go back to here, to lecture 5, and we saw the pivot example here, and I scroll down, and it'll have a demonstration of GroupBy here. So it's kind of doing the similar thing. And one thing that I think I mentioned it in maybe in the slides, it's actually in the code. That if you do not specify, if you just run AGG or aggregate, and you leave out this part here, then the AGG doesn't really know from just the GroupBy operation which sort of columns to involve in in this ag functions. So here you can see I want to run AMMD, min, max. And if you look at the original data set here, I'm gonna go back up here. Look at the original data. So it's got name and then year, okay, 2 numerical columns. But if I wanted to add, let's see, go back to that GroupBy. Let's say that I say I want to do also year. Oops, I want to take out this print statement. Hang on 1 minute. It's going to create too much noise in my output. And this again. So now look, because I specified a second column to focus on the numerics, on the AGG, it's saying look at these two columns for performing these functions, not just one. And then here I'm getting the count, the actual AMD output, as well as the min and max. So you can see the sort of the intermediate values of what AMMD is doing, okay? This is a really kind of simple example, but when you are doing a little bit more complex kinds of functions, you can actually have it do multiple or more complex functions in here, okay? So here, just another example I added into the Jupyter file about so this one here is, so you see that these baby names is saying how many people like Michael were born in a certain year. But instead of saying, instead of being interested in the min and max, but maybe you're interested in how big of a span of data is it across, right? Is maybe like say a certain name was really popular only for a short period of time, or maybe Michael was so popular that it like was so popular long ago and it's still popular now among boys' names. And you can see like the number of rows of this Michael name is just so many, and that you can actually see that compared to other names, okay? And that's what this show count is doing. It's just here you can see that certain names have n number of records across all those years. Okay. If I take out the year, then it'll be a little more meaningful there. It's saying like, for example, for the name Aiden or Zion, not that there's only 13 babies born, but 13 rows of data. Okay. All right. So here's more group by. So it's important to understand the data structure you're dealing with. So here you can sort of see that when you do a group by and you run the ag function, you're getting back a data frame. It's got too much noise in the data because I had included the print and I did a run all. You can see the columns. This one, what was it? Okay. This was getting the data structure and then showing the type of data that's involved here, which is a data frame. Okay, and this one here, when you can then sort your data that you're getting back. So here you've got the aggregate data, and you want to sort that data based on the first entry inside of that, based on what you got from the results of your AGG function. So here you can see that you're sorting it based on, in descending order, on the counts. Okay. So this is now the AMMD results in descending order. And just looking at the bottom part of that. Okay. Now we're going to switch back to the PowerPoint slides. Then we can do merging of data frames. Okay. So you can, there's basically two ways to do merging of data frames. You can, with one data frame object, you can call the merge function and then specify the other data frame to merge with. or you can use this pd.merge function and then provide the two data frames in it. And then you've got some of these various types of merging that you can do: left, right, inner, outer, and then cross. It's kind of similar if you have some familiarity with SQL and SQL database. This kind of merging is a similar kind of results like you do with SQL merging. Back over here, and I think I had the table merge examples further down. Here they are. So I built out some examples, some sample data frames with some sample data. Here's the left side, here's the right side, here's the inner merge. You see the left data frame, and you pass in the right data frame as a parameter, and you specify what column to do the merge on. This column just happened to be called key. Okay, then there's the okay, that's basically the inner or the intersection. And then here is a left merge. So here on the value y, it's going to use the right side data frame. And since some of them didn't have a value, then you see the NaN. And so here's now the right version. So it's just the opposite version of the left. Then you have the inner merge. So this is like the intersection again. And then you have the outer, which is basically like a union, okay? And then across, which is basically every possible example, combination. Okay. And then switch back here. I kind of went a little bit out of order. Now then, once we have data frame, there's basically two ways to do plotting at this point, which is once you have a data frame, you can actually call plot API on the actual data frame object itself, or you could use a separate Python package called matplotlib. Okay. All right. Something else. So then the example of some of the plots, I think I passed over it here. There's another one above. So here we had a data frame output that basically had the, so if you look at the actual data of this is, for example, the descending order of AMMD values, and you saw that Michael was the biggest ones that had the largest value. And then you just see it kind of just decline drastically over time. I mean, across all the names, not over time. So this is the baby names aggregate sorted. And then this is the pivot example, and pivoting on the name count on the AMMD on the count on across all the names, but not sorted. Okay, so that's just calling it directly on the data frame. And then the other way for plotting, you can see it here. Hold on. So this is also still a data frame. I think I have an example where I do the plotting with the separate library. I think it's in this one. Okay, I don't know why that's running into an error now. Oh, here, okay, here's the other example of the other plot. So here I'm loading in the plot libraries. matplotlib. And then I'm just creating a sample data. And then I'm just plotting that. Okay. That covers lecture 5.